Very good afternoon, one and all. Today we are going to see about the choice of site for hydroelectric power station. Sometimes in the questions they may give you like instead of hydro, run off river um, power station, like that, run off river power station. So don't get confused, like run off river power station we didn't study like that. What you will do is you will skip that particular question and you go to the next question, and you keep on confusing about that. So hydro is nothing but run off river, everything is same, or river power station, like that, everything is same. So don't get confused. So in the previous class we have seen the choice of site for thermal power station. Similarly, today we are going to see about choice of site for hydropower station. Okay, so the question is very simple. Unit 4 is very simple. Like the majority of the things, either are questions from choice of site of thermal power station or either hydropower station. So today we are going to see about hydroelectric power station. So like majority of the hydroelectric power station, okay, available in all over the world. Okay, everywhere you visit this hydroelectric power station, you have to go in the underground for some 200 meters, 300 meters. Sometimes the power station, hydroelectric power station itself will be located okay, from the dam, like 1 kilometer or 2 kilometers steep or 5 kilometers steep. Okay, sometimes 10 kilometers steep. Okay, so I have visited one hydroelectric power station where it is you have to go like 5 kilometers steep underground. Okay, 5 kilometer you have to go underground, that is 5,000 meters you have to go underground. Okay, via lift is there, so you have to go via lift. Okay, so that lift is going for 5 minutes or 10 minutes to reach that particular place, because 5 kilometers that lift has to travel, no? Otherwise road wise also connected inside a canal deep. Okay, so road also connected, road also it will take some 6 or 7 kilometers you have to travel underground road. So you have to reach that particular turbine, that is generators. So why they are constructing very steep inside the from the surface of the earth, from the surface of the earth. So you have to go like 5 kilometers, 2 kilometers, 1 kilometer steep, because so you have to get more potential energy of, that is kinetic energy of the water. Okay, so more the energy, more the power generation also more. So like if you take 100 megawatt of turbine, that runner has to runner has to turn. Okay, runner has to turn, that is not of 1500 rpm, as you are running the more like generator for 1500 rpm in the your labs. No, it is not like 1500 rpm, it is only 200 rpm, 200 rpm only that runner will be running. Okay, but even though 200 rpm that runner, because that runner is not of like a very small size, it is of 10 meters, 15 meters, 20 meters, it depends on the type of generators and as well as power generation. So 100 megawatt that runner has to generate, 100 megawatt that runner has to generate. So that water is hitting at 120 kilometer per hour maximum, 120 kilometer per hour. Imagine, that is the maximum speed of a normal train. Okay, normal train. So the maximum speed is 120 kilometer per hour. So that much pressure that water is hitting the runner, so that the runner is turning. Okay, so that runner is coupled with your generator, 100 megawatt or 200 megawatt generator. Okay, so the pressure is very more. Okay, if we stand inside that, okay, so imagine you are standing in front of 120 km per hour train. Okay, so the train is running 120 km per hour. Like you are standing in front of the train. Okay, so that much pressure within like microseconds, you'll be taken off like anything. Okay, you'll be taken off for like 500 meters, 200 meters, so you'll be taken off. So that much pressure we are giving in the penstock, that much pressure we are giving in the penstock, so that the runner is turning. Okay, so pressure inside is very very more. So if we are going for so much steep inside, okay, so much steep inside the level ground level, so you will be getting more and more pressure. If you go for 1,000 meters, you'll get some pressure. If you go for 5,000 meters, you'll get some pressure. If you go for 10,000 meters, you'll get more pressure. So from the level of the dam, how much kilometers you are going inside, then the meanwhile the pressure inside the, okay, velocity, water speed of the water also will be increasing. Okay, so that is the concept. And also the topic is choice of site of hydroelectric power. So how to choose this hydroelectric power station? Okay, so imagine you are constructing your hydroelectric power station nearby your house. Okay, nearby your house, where the water availability is not there. Water availability is not there. Just like that, you are constructing the hydroelectric power plant nearby your house. Whether you may be able to get the water pressure nearby your house, definitely not. Okay, so if it is situated near to the dams, near to the rivers, okay, even though near to the rivers, that water has to be stored somewhere else. Okay, even in the river also, you can construct, but only of mini hydropower plants you can construct, only of 5 megawatt, 10 megawatt, 2 megawatt mini hydel power plant you can construct, but not the like 100 megawatt or 200 megawatt, 500 megawatt, that is 100 into 5, 500 megawatt, 100 into 10,000 megawatt, like that we can't able to construct. Okay, so what they will do is this dam may be of many stages: stage 1, stage 2, stage 3. If you visit any dams, that dam might be of like 3 stages, might be that, or 2 stages. It depends on the location of the dam, and how steep the mountain is. Okay, so imagine like two mountains are there like this. Okay, so one mountain is there here, so another mountain, so in between you'll get one gap. Okay, so that is called catchment area. So two mountains are there, two mountains are here, one mountain, here one mountain, so in between that you'll get one gap, that is called catchment area. In the catchment area itself, you can easily store the water. Okay, so no need of digging dams, digging deep, okay, trench and deep okay thing. So simply like that you can store the water, no need of constructing dam itself. Okay, nature itself there acting as a dam, and also you can store the water, you can store the water in between the two mountains. Okay, so simply like that, if you go for some other construction work, you can store more water also in between the two mountains. If you dig more okay sand from that place, and you're constructing artificially, then you can store more water. In some other, in many of the places, nature itself giving the hand. Okay, nature itself giving the hand. In that scenario, no need of constructing the dam. Okay, in the catchment, that is called catchment area. Catchment area itself, we can store the energy. Otherwise, what we need to do is we need to construct the dam. So constructing the dam is not at all an easy task like constructing the building. Okay, so imagine like if you're constructing a building, if you're constructing a home, definitely it will take 6 months, more than 6 months or 8 months like that. Okay, normal like 2 BHK or okay, so one floor you're constructing, minimum 8 months it is taking to construct the whole process. Okay, imagine you're constructing a dam for like, even though the structures only one structure, but you're constructing a dam for 10 kilometers, 20 kilometers like that. So 20 kilometers you have to dig, 20 kilometers, like this much size, and also steep, like 150 meters, sorry, 150 feet, 150 feet, okay, deep you have to go inside. So 150 feet deep for 10 kilometers or 20 kilometers is not at all an easy task. So even though we are with the technology, like it will takes like to 1 year, more than 2 years. Okay, maximum 2 years, minimum 1 year to 1.5 years it will take. Even though if you work for 24/7, then it will take more than 1 year. Okay, more than 365 days it will take for even 20 kilometers itself. So imagine 30 kilometers, 40 kilometers, 50 kilometers you need to construct, means it will take some 2 years, 3 years, 5 years. Like in olden days, they took 5 years to construct a dam. 5 years, 10 years, okay, and all they have done. But due to the technological development, even though if you construct, definitely it will cross more than 1.5 years. Okay, so more than 1.5 years is like 500 days. Okay, 500 days minimum it will takes to construct a dam. Constructing a dam is not at all an easy task. Okay, so by 24/7 you need to work. Okay, not like that. So if they give the contract, if they give the contract for 30 kilometers, 20 kilometers, okay, so that construction company has to complete within 2 years. They come up with a bond for 2 years. They need to construct the 30 kilometers, means they have to work for 24/7, 24/7 for 2 years fully. Then only that thing is possible. Okay, because you have to go in this velocity, like deep also 150 feet you have to go inside. So 150 feet is not at all an easy task to dig. So that will take more amount of time consumed is very, very more. Then availability of the water. So that river has to flow, ever flow river. So in 365 days, that river minimum 300 days you have to get the water. 300 days you have to get the water. Then that dam has to fill. Okay, even though the water is running, the water, incoming water from the river should fill that dam. Okay, fill the dam of this many TMCs of water, like 5 TMCs of water, 10 TMCs of water. And also that if you take the um, depth of the water, depth of the dam, it is like 200 meter, 200 feet. Okay, so minimum you can store like 150 feet. If you cross more than 150 feet, then that the dam will damage. Okay, like that many constraints are there. You could not simply store the water. So maximum capacity, you could not simply store the water for 200 feet and all. You could not able to store. So only there is some limit. So only 150 feet only you can store. Then sometimes 100 feet only you can store, even though the dam is 200 feet deep depth. You can store only 120 feet of water. Okay, so if you store more than that, then the construction of the dam will get damaged. Okay, so in some foreign countries, in China, recently they blast the dam. Why? Because the water due to the rainfall. So like I think 1.5 years or 2 years before, so China got heavy rain for like 1 week. Okay, so like every dam and every streets, everything got flooded. So in that scenario, what they did is they bust one dam itself. Okay, so with some bombs, they bust the whole dam structure. Because why? Because if you didn't bust the dam, that whole dam will get damaged. So only thing is that gates only you can reconstruct. So they have busted all the gates, like 10 or 20 gates they busted. Okay, so all the water inside the dam is came out, and it flows, and it reached that sea or ocean. Okay, so that water storage capacity also very important in the thing. And also you should construct near to the rivers, rivers, where the rivers, okay, water, incoming water should be more. Okay, and also canal also they are building, and we don't know how much water we will receive from the canal. Okay, so only in the foreign countries, majority of the foreign countries in US, in that countries, the canal is also getting filled. Canal is also getting filled. But the countries like India, like a canal, most like lakes, if you see like lakes are not filling that much. And the canal we are constructing the canal artificially, and it is due to that flow, the canal is also filling. Okay, so we are having some parts, some canals also, after the dams, for agriculture we are having small canals also. And what we are doing is, now, before 10 years only, we are constructing the mini hydel power. Okay, so previous 10 years before, we are not having mini hydel power plant. So only major power plant, like 100 megawatt, 500 megawatt, like that only power plants are there. So now, due to the scarcity of water and the ever increasing in the demand, what we did is we plan to construct a mini hydel power plant of 5 megawatt, 10 megawatt, 15 megawatt, 20 megawatt, like that. We are constructing wherever the possibilities are. So once if the water is opened from the dam, okay, so we can't able to store that water. So only thing is that we need to pump that water to the first stage or second stage, like that. So pumping the water, it will take more amount of like 70 percentage of power is needed to pump that water back to that dam. Okay, so like say for example, the 100 megawatt that particular penstock, from the penstock 100 megawatt you are generating means, minimum you need 60 to 70 megawatt of power to okay, take that water, that is take pump that water from this lower stage to upper stage. Okay, so only 70 percentage you need, that much power you need to pump that water. So in the non-peak hours, not in the peak hours, in the non-peak hours where the water availability is more, in that time what and also power availability is more, where the load is very less. In that time, what they will do is, they will pump the water back. But even you need 70 megawatt, you generate 100 megawatt, but you utilize 70 megawatt. So only 30 megawatt only you can utilize in that non-peak hours. Okay, in the pumped hydro storage plant you can do like that. Okay, so that scenario also prevailing in the practical scenario. I'm telling about the practical scenario. And also availability of water, and storage of water. You need to construct the dam. Okay, there are wide variation in the water supply from the river or canal during the year. Okay, so river you can't expect 365 days water from the river, and also the canal means we are constructing artificially some canals. Okay, so in that canals also how you will get water from the river or from the dam. Okay, only thing is that if you open the water from the dam, or if you open the water from the river is flowing, ever flowing through that canal, then you will get the water in that canal. So throughout the year, so in a year they will first they will evaluate, estimate the amount of the water, how much in a year, 365 days. So how many days that water is flowing in that particular dam or in the canal. Okay, so that they will like a public works department is there, na? Public PWD, that department will taken care of all this, what is the amount of the water available in the dam. So if it is available, like we are having 10 TMCs of water, or 20 TMCs of water, how much how many days that the water will come for constructing 500 megawatt from that particular dam. Daily we are generating 500 megawatt for 8 hours or 10 hours. So how long days it will come. Okay, so it will come for 100 days. So if it is water, incoming water is this much level, then it will prevail for 100 days, it will prevail for 200 days, like that they may estimate. Okay, depends on the incoming of the water also. And sometimes if it is rains, then we'll be very happy. Okay, because water will come to the dam like anything, so that the dam will fill. Okay, so if it is not rains, then we have to depends on the river, where the incoming flow from the river, so that we have to depend. Okay, so somewhere in catchment area, if it got more rain, then the catchment area will fill. From the catchment area, slowly they will release the water to the dam. Okay, so catchment area will be of like from the ground level, I'm telling, from the plains, like ground level, catchment area will be of like 1,000 meters in the up direction, 1,000 meters in the up direction. Okay, so 1,000 meters from the sea level, from the base sea level, 1,000 meters up means, so catchment area is in the 1,000 meters means somewhere around some around 700 meters, your dam is there. So from 1,000 meters it is filling the dam. Okay, so that is the first stage of dam. So next that water will flow for some other kilometers, some 10 kilometers, 20 kilometers. Again they will construct the second stage of the dam. Okay, second stage. So all the water whatever the water flowing from the first stage, it will store in the second stage. Second stage also we are generating some 500 megawatt. Stage is third stage. Third stage it is flowing for another 20 kilometers, and third stage also that the dam is filling. Okay, so third stage also what we are doing is we are storing some water, and we are generating some 300 megawatt. So from first stage we have generated 500 megawatt. Second stage again 500 megawatt. Third stage we again generate some 300 megawatt. So 500 plus 500 plus 300. So 1,300 megawatt we are generating from that dam itself. From that 1, 2, 3, 3 stages dam, we are generating 1,300 megawatt of power. Okay, like 500 plus 500 plus 300. So while constructing the dam itself, they will construct that like that, stage 1, stage 2, stage 3, like. But nature also has to give the hands. Okay, so if the mountain is very very small, then we can't able to construct this many stages. If the mountain is very very steep, very very steep for like what I said, no, like 2,000 meters or 3,000 meters up, the mountain is 3,000 meters up, na. So we can construct 3 stage or 4 stage like. But even the nature has to give the hands. But even we can construct the dam, but it will take more okay, construction cost. Okay, initial principal amount you need to spend more on that. It is not a very easy task like you're constructing your house. Imagine you're constructing 1 BHK itself, it is taking like 30 to 30 lakhs, 30 lakhs of rupees. So you're constructing for 30 kilometers dam, 30 to 40 kilometers. So it will come in crores, like 200 crores, 500 crores, 1000 crores you need to spend on the constructing the dam itself. Okay, so if you're lucky that nature itself giving the hands, so it will reduce to one half or one by three, or okay, so 1/4 amount only you can spend to construct the dam. So this storage helps in equalizing the flow of water, so that any excess quantity of water at certain period of year can be made available during the times of low flow in the river. So this also possible. Okay, so again this leads to the conclusion like site selected for the hydroelectric plant should provide adequate facilities for erecting the dam and storage of water. Okay, so like nearby your home you can't able to construct the dam. Okay, so that should be very very steep. Okay, it has to come like this, then only you can construct the dam in this area. In this area for 10 kilometers, 20 kilometers, you can go further, little bit further, and you can construct. Okay, so wherever the possible, you can't able to construct the dam. Okay, so only in that particular place in the catchment area, so where mountains is there, mountains are more, then you can easily construct the dam. Instead of like as I said now, instead of spending 100% of amount for constructing the dam, so only 20%, 25% is enough to construct the dam in that hilly areas, mountain areas. Okay, so where the storage of water is also very very easy, and also cost and type of the land. Okay, so imagine you're a private company, you need to construct a dam. It is not at all possible, not at all possible, because you need to you need to purchase that land. Only thing is that they will go for lease for that particular land. So okay, they are taking some 30-40 kilometers means, so per kilometers they will go for lease for 100 years. Okay, 100 years for 40 kilometers they will go for the lease. Okay, by the end of the 100 year, so each year they have to pay the certain amount for constructing the for utilizing that particular area, because 40 kilometers space and all government they will not say. Okay, so they will give for lease only, they will give for lease for this many years, 100 years, 50 years, 20 years, like that they may give. So each year you have to pay certain amount to the government for utilizing that particular space. By the end of the 100 year, whatever the construction that is that private company did, they have to give to that government sector. They have to say, they have to simply give to the government sector at the end of the 100 year. Like similarly, what they are doing in constructing of roads, no, what they will do is government they will give the lease for like 100 years. They will give some 40 kilometers or 50 kilometers to that particular private company for 100 years. So what they will do is they have to pay per year, they have to pay this much crores. Okay, for utilizing that 40 kilometers, and they have to maintain also. And by the end of the 100 year, okay, after 100th year, they have to give that particular roads to the government itself. After 100 year, that 40 kilometers will taken care of government itself. Okay, so similarly like that, they will go for the lease for that particular land, they will construct the dam, private dam, then they will generate the power also. They will get that profit also, even though. So a certain amount they have to pay to the government. And end of the 100 year, you have to give that whole construction of the dam to the government. Okay, so that is also there. That is very, very difficult. Only government can do. Government can construct the dam. Uh, um, because government simply they will allot that particular space for 100 kilometers. They will allot simply for constructing the dam and for generating the power. Everything they will simply allot. We can't able to purchase that much amount. With that much amount we can't able to purchase, because 100 kilometers means say, buying 1 kilometer itself very, very difficult, very, very costly. Okay, so 100 kilometers means it is the construction costs will comes like anything, and also that will reflect in the tariff. So government itself they will construct the dam in their own lands. Then they will produce the power, and they will give the give to the consumers with the subsidized cost. Subsidized cost. Okay, so even though the tariff is 5 rupees, so government is spending more than 10 rupees, 15 rupees for constructing per unit of power. But even they are giving it for only 5 rupees only. So they will get the some other amount from the corporate tax. So for industries, they are giving for more amount. Okay, industries they are getting for 18 rupees, 12 rupees, like that. Okay, even though they are spending only some 10 rupees, they are giving the to industries for 12 rupees, 18 rupees, like that. So they are getting more profit from the industries. So they are managing with the domestic users. They are managing with the domestic users for less amount. We are paying only lesser. But actually, if you take the all this production of the power, everything, it will take some more than 5 rupees. So government is subsidizing that amount. They are giving, because they are getting profit from some other sectors, some other industrial sectors. They are managing with this domestic sectors, and they are giving with the subsidized cost. And also transportation facilities. Transportation facilities means you have to carry the very huge like machineries, like generators. Generators, if you take like it is very, very huge structures. You need to carry from shipyard to that particular power plant. Sometimes the particular power plant is located in the hilly areas. Okay, in hilly areas it is very hard to drive the your truck lorries. Okay, truck lorries and all, it is very, very hard to drive. It is not at all an easy task to drive in the hilly areas, truck lorries. Okay, in plains, even 1,000 kilometers, 2,000 kilometers also lorries will that truck lorries will run, and it will they will deliver that particular machineries to that particular place. But in the hilly areas it is very, very hard. So what they will do is they will assemble there itself. They will assemble all the generator there itself. If they give the okay, if you give okay bits, or if you're asking for to construct a 100 megawatt power plant in the hilly areas, so what they will do is they will take all the components inside that hilly areas, like windings, everything. They will windings, everything they will do there itself. Okay, it will take 6 months or 1 year of time to construct that whole power plant or whole machineries. Some 5 machineries they need to construct means they will take definitely 1 year to construct the machinery itself. Okay, so simply like that you can't construct a hydro power plant, and you can't generate. So minimum you have to wait for 5 years or 4 years. Now due to the technological development, minimum 2 years you have to wait for constructing the power plant. The thing is that if you work for 24/7, so that is also the 24/7 for 365 days for 2 years. Okay, 2 years if you continuously work, then that is possible. Or otherwise, if they work 8 hours shift or 10 hours a shift, 12 hours a shift, that 2 years will take 4 years again. Okay, so that is also there. So rails and roads. So sometimes trains also connected via to that particular hydropower plant for carrying the heavy equipments, machineries like that. Then roads also connectivity is there. As I said, if it is located in the plains, then it is easy. Hilly areas, it is way. And also sometimes like majority of the hydropower plants are 80 years and 100 years old in India. 100 years old, imagine 100 years old generators are even running in our country. Why? Because we are developing country. What we will do is, we will simply go for maintenance. Always we'll go for maintenance. Even the ABB machines of UK made or Italy made, German made, and Japan made generators are there. Simply it is running. China made make generators also there. Simply it is running for 80 years, 100 years. Okay. So previously, if they want to buy a shaft, generator shaft, they have to go to UK, London. Okay, so even that company itself not producing that particular components. Why? Because the company will produce that particular components for only 30 years, 40 years, up to 40, after 40 years, they will simply stop that particular manufacturing that particular components. Okay, so even the ABB company itself, they are astonishing from seeing that particular generator is running. Even their own make only, even it is running for 100 years, means that is pride to that particular company only. Okay, particular ABB make generator is running for 100 years, means that is very pride to that particular company only. That company's product is running for 100 years. 100 years, who will run for 100 years? Even no components and no, if you take any, even your vehicle also, you can't able to run for 100 years. Simply like that, a showcase, you can simply you can put it in a glass box. But running the particular thing for 100 years, vehicles for 100 years is not possible at all. I think they might be utilized for 10 years to 15 years and 20 years. After that, simply like that, they will put it in a garage or store, particular place for some only in an exhibition. They may project for this vehicle is of 100 years old, like that they may tell. But the running condition, it should be 100 years it is running or not, that is very, very big question mark. They may run only in a year, they may run for some 5 years, 10 years only. Okay, so like that, many things are there. Getting the this machineries, they're getting the components, each component for that machineries, generators, is very, very difficult task. So what they do is, they will if they want to buy a shaft, they need to go to UK. So from ship or from air, it will come, and you need to go to nearby shipyards or nearby airports, and you need to take that machinery. So that too, it is not easy. Once you give the order, means they will take some 2 months of time, 3 months of time, 100 days of time. So then only it will come, and the transportation, it will take some 10 days, 5 to 10 days. Okay, so it has to come, and from that shipyard, it has to reach that particular hilly areas hydropower station. That is from shipyard again 500 kilometers it has to travel. So many things are there in the transportation itself.